Hi everybody, today we're going to be talking about chemical formulas. So this is probably the most important thing to learn in this entire booklet because this is something you're going to be using all the way through chemistry. Any chemistry course you take, it's going to be a lot of counting. So chemical formulas are the combination of symbols and subscripts that represent the ratio of elements in a compound. Compounds have equal numbers of protons and electrons over the whole compound, so they have zero net charge. So that means that the number of positives and negatives are balanced out, and that's really important, very key to describing these things and to thinking about counting. We should be considering how to count things. So a form of sugar called glucose has this chemical formula C6H12O6. So we want to know what this means. From the formula, state the name of the elements and the number of atoms needed to make one molecule of glucose. And this is going to be an assignment we're going to have soon. So this number here only references the chemical formula from that lies before it. It does not have an effect on counting of the following elements. So the 6 only affects the C. This 12 only references to the hydrogen. So we have to be able to keep that straight. I have lots of students who make mistakes there, and they think that the 12 affects both the oxygen and the hydrogen or something. So the 6 here also references only the oxygen. So C6 means that we have 6 atoms of carbon, H12 means 12 atoms of hydrogen, and 6 oxygen atoms. So if you wanted to be able to draw this, sometimes I like to draw things, so I would think about it as like there's 6 of these carbon things, and I'm just gonna stick them together. So let's put these like this, so something like that. Oops, let's maybe connect these ones like that. So these are all carbon. I don't know. And then there's got to be, this is telling us that there are 6 oxygens. So let's just put those, I don't know, around here somewhere. 1, 2, 3, 4, 5, and I guess I missed one, 6, sure. And so there's 6 oxygens. Now this is completely not the correct way that this should look. I'm kind of being a little bit tricky with them. Something like this. You know, that actually. Okay, if I really want to get specific, we should do something like that. Okay, so there's our oxygens, and then there's also 12 hydrogens, and hydrogens are going to be, we'll just put them in white, and they would sort of stick around all over the place. Something like this. And so this is the first hint at how to draw chemical formulas and why it's important to know how to read the chemical formulas. Something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so there's our 12 hydrogens, there are 6 oxygens, and our 6 carbons. Now it takes a long time and a lot of practice to be able to do that, to be able to predict what the structure is supposed to look like, but it is possible to do. And you can do it too if you practice enough. You can even start to predict what these structures should look like after some time. So let's look at the next little practice here. In the practice, what we're going to do is we're going to be stating how many of each atom there is. So we're looking here, the sodium, there's a 2 after it, so there are 2 sodium atoms. There's no number passed after the oxygen. Apologize, I'm underneath a radiator here. So there's no number after the oxygen, so that is a 1 oxygen atom. Okay, now if you're not familiar with your symbols yet, then that's okay. We can also write, I would also accept it if you wrote sodium out, or if you wrote oxygen out. Okay. Following, we have an element, we have a compound called peroxide. And so this peroxide, also, I'm going to see if I can move my device here somewhere a little bit farther away from that. Okay, so with peroxide, we have 2 hydrogens and we have 2 oxygens. So we would write that as 2 hydrogens and 2 oxygens, or hydrogen and oxygen. Now I'm going to push you to be able to do this kind of reading as well. Now, just like in brackets, when we apply brackets in a normal sort of mathematical sense, brackets here represent multiplication. So let's start with the magnesium. The magnesium has no partner number, right? So that's going to be assumed to mean 1. So if you have no partner number, no subscript, then that's going to be 1. But the NO3 has the NO3 all together in this bracket, the NO3 all have a little partner called 2. And what that means is that there are 2 of these NO3s. So we have to imagine that we have magnesium, and then we have NO3 and NO3. So however many N's and O's and N's and O's we have 2 of them. So that means that we're going to get twice the number. So N normally has the 1 beside it. So we have like a 1N, but we have 2 of them from this 2 on the outside. We have 3 oxygens, but we have 2 of them from the 2 on the outside. So we should really collapse this up. 2 times 1 is 2, and 2 times 3 is 6 oxygens. And we can see that here. 3 and 3, that's 6. 1 and 1, that's 2. So this is a little bit trickier to do, but really, really important, and it definitely is going to help you in the next chemistry course that you take. So let's do that a couple more times. Let's do the aluminum here. So we have aluminum, the partner for aluminum, the subscript for aluminum is 2, so 2 aluminums. And then the SO4, we can say that's 1S and 4 oxygens, but then we want to take that bracket, put it around, wrap it around, and bring that 3 outside of both of them, because they're both inside of those brackets. And then we're going to finish up by cleaning up. So 3 times 1, 3 sulfurs in total. And 3 times 4 is 12 oxygens in total. So quite a few more oxygens. Let's zoom down a little bit so that we can look at a couple other ones down here. Hopefully you're okay with these other ones that are straightforward. I'll fill in them and you can check the PDF if you like after. So let's do the iron here. We have iron. It has only a 1 beside it, so we have 1 iron. And then we have the brackets, right? So in the brackets, we have an oxygen with only a 1 beside it. So we have 1 oxygen. And open a bracket around it. We have 1 hydrogen. Put a bracket around it, and then we look at that bracket. We say there's a 2 and a 2. So we actually have 2 oxygens and 2 hydrogens. Again, we have something that looks like this with OH and OH on it. So 2 of them. 2 oxygens, 2 hydrogens. Lead NO3. Let's see if we can draw that. So lead NO3, and there's 2 of them. NO3, NO3. Okay, so I see 1 lead, and then I see 2 nitrogens, and I see 6 oxygens. Now I did the multiplication pretty quickly there. If you want, you can even do it here. So we can go like 6, and we can go 2. So 2 times 3 and 2 times 1, that gives us 2 and 6. So maybe I'll zoom in here and put some notes here. So 2 times 1 equals 2. 2 times 3 equals 6. Okay, let's look at this one here, NH4. Now then, there's a little bit of an error here. If you want to get out some whiteout and fix this, that would be great. But I'm going to just fix it up myself. So the 4 should be down subscript. Okay, so let's look at this one. This one's different because the bracket is on the front number, the front formula. So we have to think that we have 1N, but it's in a bracket. We have 4 hydrogens, but they're in a bracket. And then we have the 1 sulfur that's not in a bracket. Outside of the bracket, we have a 2 and we have a 2. So that makes it 2 nitrogens and 8 hydrogens, and 1 sulfur. And that's just something that happens. You'll learn a reason for why that is in the next section, actually, as we start to talk about ionic compounds and some of the types of ionic compounds where we have this sort of system where we have to put the NH4 in front. So this is supposed to look like NH4 with a sulfur and NH4. So 2 NH4s for each sulfur. And if you add that up, you get 2 nitrogens and 8 hydrogens. All right, I'm going to give you an assignment on counting, and I hope you enjoy it. And then we will come back for some chemical labeling and naming.